Okay, you ready?
Yep, I'm ready. This is the same voice on all those TikTok videos. Recording in progress.
Welcome, everyone, to Salt Air. I am your host and community manager of Salt, Janae Andrus, and I'm here with Tom Hatch, the creator of Salt. What's up, Tom?
Hey.
We're excited that you've joined us for another episode of Salt Air, where we get granular on salt. Don't miss an episode. Subscribe at the bottom. We are excited to be with you every week talking about salt, which is exciting. And something interesting about salt is it's just really fast. So if you think about compilers, for instance, salt compilers are especially super fast. So Tom, what are your thoughts and feelings on going through the life cycle of a salt compiler today?
Well, I think that makes a lot of sense. There's a lot of people who they can get a lot more out of using salt states if they understand how the compiler and the runtime actually work. And so it's a very, very powerful system, but it's not built the way most compilers are built. It's built it's built differently because it's doing different things than most language compilers.
That makes sense. And now you mentioned this is sort of a step beyond understanding salt states in depth, which we reviewed in an earlier episode. So if you want to dive into that, we do have an earlier Salt Air episode on salt states, but this will be fun to dive into compilers today.
Yeah, definitely. So when we look at the salt compiler for salt states, how it works is, again, it's a little different from a normal language compiler. A normal language compiler typically uses the LALR algorithm for parsing the language and then tokenizes everything into tokens and then goes through an expression system to create an abstract syntax tree. And then from the abstract syntax tree, we derive the actions that need to be taken with that language. Salt's compiler is different because what I did was look at things and say, look, what we want to do is be able to have a textual representation of the actions that need to be taken. And in doing so, I was able to dramatically simplify the syntax. And so syntactically, salt states look like configuration files, which I tried to design that so that it would be a lot easier for system administrators to be able to use salt, so that it would be easier for them to learn how it works and easier for them to interact with it. And so that right out the gates, a system administrator who doesn't necessarily have as much programming background is able to write very, very powerful configuration management routines. Because one of the things that aggravated me a lot about the other configuration management tools was that they were going around and saying, people who are managing systems need to learn how to code. People who are managing systems already have to understand a lot about how to manage those systems. They have to understand how operating systems work, how application deployment works, how clouds work, how cloud APIs and interfaces work. And to sit them down and say, now you have to become a full-blown software engineer too, isn't accurately representative of what's going on inside of that industry and inside of their careers, because these people need to be up on what's going on with their infrastructure.
No, this makes a lot of sense because you need people to be able to be expert at what they're expert at, right? And to focus on their lane and their area, and to ask them to do all the things probably just means you're going to be less good at everything. So empowering people to be experts is really powerful. And it sounds like that's a big part of how you design salt. We always come back to this in Salt Air episodes. You always come back to, whether you mean to or not, how salt is just easier and it's approachable and it's meant to not only be easy to use, but to make things easier.
Right. The core design principles of salt is that it should be really easy to use. That's always been the goal, but at the same time, not weak. When we look at other systems that are,
Can that be our new tagline for salt? Salt, not weak.
and not weak.
I just really enjoyed that.
Easy and not weak.
Not weak.
Because
that should be our next t-shirt.
If I'm so bold, there are other configuration management tools out there that are very, very, very easy, but they're also very weak and they're also very limited in their scope. And so Salt is made to be easy to use, but also powerful.
And that's great. I won't ask you to name names, but it makes sense that other configuration management tools that are easy to use just don't have the strength. So Salt, not weak. Next t-shirt. But please continue about the compiler.
So the compiler, how it works is that our first phase is what we call the renderer phase or the render phase. The render phase allows us to take SLS files. So in Salt, SLS files, the SLS stands for Structured Layered State, which is a new term or a new explanation for SLS. I think I actually mentioned what it used to stand for in an earlier Salt episode, and I'm downright embarrassed.
Salt systems.
A salt state.
State. We talk about this in one of our first vocab episodes.
It is a structured layered state. Now, what that means is that we can layer how the logic is defined. And what you're trying to do inside of a Salt state is have the defined data structure, which represents how you're going to enforce state on your system or your cloud or your API or whatever it is that you're managing with Salt. And the compiler I'm going to walk through is also for this. I'm going to walk through Salt compiler. Some of you may be aware of another project called Item, which is up and coming that I've been banging away on for a while. The acquisition has distracted it a little bit.
Item is another one of our open source projects. It's IDEM. Item.
Yep, it's short for idempotent. And so its compiler is very similar to what we have inside the Salt system. Item also uses a structured layered state as the first step. And so we put that through the renderer. The renderer is a plugin system because we just make everything freaking plugins in Salt. And so it's easy to create renderer plugins so that you can use any language that you want. By default, you just define these states using YAML, and then we allow templating using the Jinja templating language. But you can use any templating language you want. If you hate YAML, you can use TOML or JSON or, heaven forbid, XML to define them. And okay, so I say heaven forbid XML.
I was about to call you out for that. No judgment.
So I haven't actually made a public XML joke for a while because for a long time I would say, well, you could use XML, but nobody's ever wanted to. So we don't have built-in support for XML. And then I would follow that up with, because who would want to use XML for anything? XML is terrible. And I said that once to a crowd of people at Oracle.
Oh my.
And the creator of XML was in the room.
Oh no.
And I've never backpedaled so fast in my life. I
got a cramp backpedaling on that one.
he was actually pretty chill, right? And was saying things like, well, yeah, you're representing a data structure, and XML is fundamentally a document representation. And I totally understand that this is not necessarily your go-to for a data structure. So he was really cool about it, but it's still very
Oh, he sounds awesome.
Yeah. And most people who have created publicly used software have to realize that you have not solved world hunger.
Yeah, they know how to be reasonable humans about what lane they're swimming in.
Right. There are plenty of problems in my designs.
Yes.
Okay. This SLS data gets rendered to what we call high data. High data is just high-level data that is the entry point for the compiler. And we can actually deconstruct the compiler using Salt. And how this works, if I share my screen real quick here, is that when we call the state functions, there are a lot of different functions that people are generally not aware of. inside of salt states. Normally, people just call state.apply, which is your generic, hey, I'm going to run states now. But you can actually inject a routine onto multiple layers of the compiler and the runtime. And so, for instance, you can say, hey, I'm going to run state.high. So state.high state was actually the original execution of states before we introduced state.apply to make things easier. But so you can say state.high, and you can actually send on the command line a high data structure directly using a YAML parsable syntax. And so you could just say, hey, I'm going to run this one state directly using state.high. But high data then gets compiled down to what we call low data. And low data is what the runtime actually uses. And so the execution runtime is using data which has been spread out for kind of like, you can think of it kind of like assembly for salt. And so it's simplified for the sequence that's going to happen. We've taken all of the little bits of information from the high data set and turned it into, this is the order in which we're going to be executing. And so what happens is that we take that high data from the SLS file, and at this point we've already run the Jinja or all of the rendering. So all the commands from rendering have been executed. And then we take that high data and we break it down. We pre-process it a couple of times to say, are there any high-level flags that need to be reconciled? And so one of the things that exist inside of SALT is something called requisites. Requisites allow us to create relationships between different SALT states. So that we can say that SALT A requires SALT B. So SALT A is always run after state B, and only if state B runs successfully. We also have what are called requisite ins. A requisite in is a reverse requisite, where we're able to say, I'm state B, and I'm going to tell state A that it requires me. And so we reconcile requisites, or requisite ins. So the runtime doesn't know what a requisite in or a reverse requisite is. We reconcile that at compile time. The runtime doesn't know what include statements are, doesn't know what exclude statements are. Those all get reconciled right when we do the compilation, the pre-processing of the high data. And then once we have clean high data, then we turn it into low data. And so high data is just a big dictionary data structure that is this JSON compatible data structure. And then when we compile that to low data, then it's just a sequence of steps. And that sequence of steps is created based on a number of things that happen in the high data. And so this is another thing that's really cool about SALT that a lot of people get confused about. Sometimes people accuse us of running SALT in an arbitrary order, and that's just not true at all. This is because the original implementation of SALT didn't run in the same order that it was written in the states. We put everything into lexicographical order so that it would be deterministic. But in SALT 0.17, which is a long time ago, I mean, this is like early 2013, we changed it so that SALT would evaluate each of these steps in the order in which they're defined, which makes writing SALT states a lot easier because you always know what order they're going to run in. But that's the order of evaluation. So then we get into the runtime, and so we've got a finite deterministic order of evaluation. And you can manually change the order of evaluation. You can say things like, always run this one thing at the first. And so that allows us to make something that is, again, idempotent, deterministic, declarative, but also imperative, which gives us every capability that you want inside of a config management system.
That's fantastic. And that is essentially the compiler lifecycle with a few additional details in between about runtime and all kinds of other details. That was fantastic, and definitely a granular view of a SALT compiler. Tom, thank you so much for running us through that. It was awesome. I think we all got a lot out of it. And thank you for joining us at Salt Air. We will catch you next week. Don't miss us. Subscribe at the bottom, and have a great day.